So this is question 2 related to the particulate nature, the structure question. In the question, matter can exist as a solid, liquid or gas. The arrow shows some changes of state. You can see the arrows. Name the change of state represented on the diagram A. What diagram A represent? The process. So a solid is turning into liquid. We call that as melting. What about B? In B, a solid directly turned into a gas, so we call that as sublimation. What about C? A gas turning into a liquid. So when a gas is converting into liquid, we call that as, it's a gas changing into liquid, not liquid change to gas. The arrow direction of the arrow is from gas to liquid. That's why we call that as condensation. Because for A, the direction of the arrow is from solid to liquid. For B, it is from solid to gas. And for C, it is from gas to liquid. And the second part B, why the energy has to be supplied to turn a liquid into gas. So if we want to convert a liquid into a gas, why we have to supply energy? To move the particle apart, that's one answer. What about others? So particles can move apart, yes. What else we can mention? To make the particle more further apart, yeah, that's right. Not about temperature, we don't mention normally the particle. Or we can also mention, that's right, your most of the answers are correct, to make the particle more energized so they can move further apart or move the particle further apart. Or you can also say to break the bonds between the particle, like whenever we are changing the state, we are supplying energy. Like if we want to convert solid to liquid or liquid to gas, why we have to supply energy? Basically we have to break the attraction between the particles. That's why we have to supply energy, because like example, in a liquid the particles are closer compared to that in gas, so and they have attraction between them. The red line is representing the bonds or attraction, so we have to break this bond. So how we can break this bond? By supplying the energy. So the moment we supply energy, the bonds will break, and as the bonds will break, the particle move away from each other. So basically to break the force of attraction or attraction between the particles. In part C, the diagram represents same number of particles of gas in two containers. If the temperature is not high enough, how would we be able to break the bonds or attraction? It does not depend on temperature. Even if you check, there are some of the substances, if you check the boiling point for some of the gases, the boiling point is -30. So -30 is not a high temperature, -30 is a low temperature. So it depends on why some gases or some substances have high melting, a high boiling point, and some have low boiling point. Like when you take an example of water, the boiling temperature of the water is 100. And when you take the example for say alcohol, the boiling temperature for alcohol is 78. So why even the two substances are liquid but they have different boiling temperature? Because they have different attraction or force of attraction between the particles. Alcohols having weak attraction between the particle, so bonds can break easily. That's why you need a small amount of energy. Whereas in water, the particles, they have strong attraction between them, so you need more energy. That's why you need higher temperature or higher boiling point for water. So it is not necessary that the boiling temperature or temperature should be high, because even some of the substances, their boiling temperature is in negative. Even oxygen, it is minus 190, 189 or 196, not exactly sure, but it is in the same range. So minus 196, so it's a very low temperature. Is it clear, Sign? In part C, the diagram represents same number of particles of gas in two containers D and E. So we have two containers D and E which have different volumes. So the volume, the size of a container is different. The two containers are at same temperature. In which container will the pressure be higher? And explain your answer. So what could be the answer for this? Which container the pressure will be higher? D or E, and what could be the reason? First thing, the container in which the pressure will be higher is E. E is the right answer. But why E is the right answer? If you remember the yesterday's lecture, we began with the concept that the pressure of the gas means how many molecules are hitting the wall of the container. So the correct answer for this one is E. And what is the reason? Because the greater number of collisions with the wall of container. Because it is a small space, so when small space, molecules will collide, or greater, more times they will collide with the wall. It's a large space, so molecule will take time to collide with the wall of the container. Is it clear? Discussion? Yeah, there are many reasons. There can be many reasons, but what you have to do, you have to answer according to the concept which you have studied. The concept which you have studied is the pressure of the gas depends on the number of the molecules collide with the wall. If more molecules collide at once, higher pressure. So you have to use the reason only, or give the reason which you have studied related to the topic. And they already mentioned both at same temperature, so the particles are moving with the same speed, but at once more molecules will collide for E as compared to that of D. Okay, next question. Particles behave differently when different physical states. Solids have fixed volume and a definite shape. Gases have no fixed volume and take the shape of container. Describe the volume and shape of liquid. What is the volume of a liquid and what about the shape of the liquid? So liquids do not have fixed shape, but they take the shape of container, but they do have fixed volume. Or you can also write they have definite volume and they take the shape of the container. And you have to mention about volume as well, because they ask for both. Describe the volume and the shape of the liquid. So you have to explain both of them. In IGCSE, there is no half mark. Like for example, one of the student write that liquids do not have, for example, the student mentioned liquid do not have fixed volume or fixed shape. So even though fixed shape is correct, but fixed volume is not correct. So even if your half of the answer is wrong, because it is of 1 mark, so you will not score any mark. It will be 0. Because there is no half mark in IGCSE. They don't give you mark as 0.5 or 0.25. Either you get full marks, like in whole numbers, you will always get the marks. Next question, complete the table to show the separation, arrangement and movement of particle in each. One of the row is done for you. Like liquid, they mentioned particles are touching each other. Arrangement of particle is random and move over one another. That's for liquid. But what about solid? If I want to answer first one, separation of the particles. Are the particles touching each other? You're vibrating at one position, tightly packed, and they're touching each other. Because with reference to the reason why they give you the row here, like they complete the row, so they want you to use that row as standard. So particles are tightly packed together. If you mention a vibration, vibration is a movement here. That's a motion, movement. So in short, what we can say, the particles are packed together and touching each other. So separation of there is a movement, there is a vibration. You don't say the particle does not move. So the first answer for separation of the particle are touching each other. What about the second one? Arrangement of the particles. So particles are arranged in a fixed pattern. That's right. Good. And what about the movement of the regular pattern, orderly arrangement? You can mention arrange in a fixed pattern, regular pattern, or arrange in order. What about the motion of the particle, movement of the particles? So they vibrate about a fixed position. Even the term vibrate will give you the mark. So if you just write vibration, you will get the marks. What about gases, the separation of the particle? What we should write? So I can write the particles are not touching each other. arrangement of the particles in gases. Is there a arrangement, regular arrangement? So particles are randomly arranged in gases. When we compare, the particles are not touching each other. It means the particles are away. They may collide. They may collide with each other, but they are not in continuously in touch of each other. But in liquid, the particles are continuously in touch, whereas in solid as well, the particles are in touch. Yeah, they can collide, collision can happen, but the question touching each other here refers to like continuously they are in touch with each other. That's why we are saying they are not touching each other. They may collide, but that most of the time they are not colliding or touching each other. What about the movement of the particles? If the volume for a gas is low, even in that case, the particle may not touch each other. They may collide more times, but do not touch each other continuously. And same thing, if you compress the gas too much, the gas might turn into liquid. And movement of the particle moving rapidly in all directions, or you can also in all direction you can also mention random. Even I can write a one word answer here. I can write randomly. They are moving randomly, so that will also give the mark. Name the following changes. Ice turn into what? Ice turn into what? Turning to water. What we call a solid carbon dioxide turned directly into a gaseous carbon dioxide. We call that as sublimation. Question 4. In this question, the graph shows how the temperature of a substance changes as it cooled. So this is actually a cooling curve we call, in which we remove the energy. So what we have here, when the temperature is constant, it means the particles, if the temperature is kept constant or temperature is constant, it means that there is a change in the state, like either a solid turned into liquid or liquid turned to gas, or a gas turned into liquid or a liquid turned into solid. And because it is a cooling curve, so in a cooling curve we remove the temperature. So when we remove the temperature, it means in this curve the gas will turn into liquid and a liquid will turn into solid. Now what you have to do, you don't have to write the process, you just have to use the letters to answer. So they mention each letter on the graph may be used once, more than once, and not at all. So the letters which are given here, S, T, V, W, X, Y, and Z. You can use them once or twice, or you may not use at all. So the first one, the particles in the substance have the most kinetic energy. The most kinetic energy, basically most kinetic energy means the highest temperature, and they have the highest temperature at S. So S is the right answer. The particles in then this is done. The part two, the particles in the substance are furthest apart. For a hint, when I write the state, this will be gas. This is a gas is turning into liquid. This will be liquid. A liquid is turning into solid, and this will be solid. So further, the particle in a substance are furthest apart. This is solid. Z is solid. So the correct answer is S again. Because S is a gas, and gas at high temperature, the particle will be further apart. The substance exists as a both gas and liquid. So which region we have gas and liquid both? That's V. The meaning I wrote on the letter, it means it is showing the states. So what you have in the beginning, in this region, what you have a gas. When the temperature is constant, it means a gas is turning into liquid. So which two states you will have here? You will have gas as well as liquid. Again, a temperature is changing. So in this region, what you will have only liquid, because when the temperature change, the state does not change. And when the temperature is constant, the state changes. Yeah, in this region, we have both gas and liquid. It means that there are gas particles which are converting into liquid. So we have both states. And here we will have liquid and solid. And from Y to Z, we will have only solid. Then use the graph, estimate the freezing point of the substance. What is the freezing point of the substance? The freezing point when a liquid is turning into solid. So what you will do, you will draw a horizontal line. So when you draw the horizontal line, it will come out around 150. So the freezing point, the temperature at which the substance is freezing, it is around. But it should be a horizontal line. So to be accurate, because my line is not exactly horizontal, so I should draw a horizontal line. So when I draw exactly horizontal line, yeah, under this I wrote liquid and solid. It means the liquid is turning into solid. So we have both state because the temperature is constant. It is not necessary that a liquid turning into solid at 100. Different materials, different substances have different freezing points. So it appears like 140 because it is one. There is no number, but numbers are not written. So you can estimate this. You can mention 140 or you can mention 145 or 130. So approximation is there. Any answer from 145 to 135 is acceptable. Because they are asking for a freezing point. The term freezing point means when a liquid start to change into solid. So this region you was having all liquid, but when you draw a line, see this is a horizontal part, this is a part where a liquid is starting to turn into solid. So when I draw a horizontal line, that horizontal line does not match with 150, that is below 150. That's why I'm not writing 150, it's less than 150. So any answer less than 150 is acceptable here. Name the change of state when solid turn into gas. So we called sublimation. What term describe what happened basically in part D? When smoke particles are viewed through a microscope, the smoke particles in air appear to jump around. What we call this? We call a Brownian motion. And why the smoke particle move in this way? So what is the reason why the smoke particle undergo a Brownian motion? Yeah, that's because it's of 2 marks. So this is one, as they're continuously collide, the air molecules are continuously hitting from all the direction, and this collision cause a random motion. So air molecules are continuously hit, the dust particle or smoke particles are continuously hit by air particles, and this causes a random motion. Or you can mention here that lighter air particles are colliding with the smoke particle, exerting force and causing a random motion. This is a similar question, question 5. Now, instead of smoke particle, they are using a term dust particle. A dust particle in air move around randomly. What term describe the random motion of the dust particle? What we call the random motion of the dust particle? So that's a Brownian motion. Identify the particles in air which cause the random movement of dust particle. Basically, what are the particles present in air? Air is a mixture of which gases? Air contain which gases? So it contain oxygen, nitrogen, carbon dioxide. So the particles which are responsible. So the question is identify particles in the air which cause a random motion. So you can mention oxygen, only two you have to write because it's of 2 marks. So you can mention oxygen, you can mention nitrogen, because about 78% is oxygen and 21%, 78% is nitrogen and 21% is oxygen. So mainly it is due to nitrogen and oxygen. Why I did not write carbon dioxide? Because carbon dioxide proportion is so small, it is about 0.04%. That's a very small proportion. But when you have nitrogen, about 78% by volume contain nitrogen, and when you check oxygen, about 21% oxygen. So major proportion, the total sum, it is about 99%. So 99% of the air consists of nitrogen and oxygen. So these are the particles responsible for most of the collision. Yes, there will be a collision of carbon dioxide with smoke or a dust particle, but most of the collisions are due to nitrogen and oxygen. So one mark is for mentioning nitrogen, and the second mark is for mentioning oxygen molecules. Explain why the dust particle move in this way. So it's the same answer what we have discussed, that they are colliding with the lighter air particles, air molecule hitting the dust particle, which cause the random motion. Part B, when chlorine, which is Cl2, the mass of chlorine is 71, is put into a gas jar, it's spread out and fill the gas jar. When a bromine gas, the mass of a bromine gas is 160. Chlorine is 71, whereas bromine is 160. Put into a gas jar, it also spread and fill the gas jar. The process takes longer for bromine than of chlorine. What term describe the way the gas particles spread out? What is the term used when the gas particles spread out from one place to another? So that is called or known as diffusion. Use the data from periodic table. Data from periodic table means use the masses. Why bromine take longer to fill the gas jar than chlorine? But why the chlorine gas is faster? That's a question. So you can mention why bromine took longer time. Chlorine is lighter or bromine is heavier. So it will diffuse slower. Explain why. Yes, you can mention this answer as well. Then the third part, why increasing the temperature increase the rate at which the gas particles spread out. So when we increase the temperature, why the gas particle or diffusion occur at a higher rate or a faster rate? So the particle gain more energy, they will move faster, high temperature, more energy. So the rate of the diffusion will increase. Then this is the last question of this exercise, but the last question I will not solve because I will share this file as a weekly homework. So we are done with topic 1, the particulate nature of the matter. Any question related to the topic or related to the class? Any doubt? So I'll end the session now and share this recording with you.